Sorry for the date change. We needed me to fill in as a speaker. Yeah, that's great. That's totally fine. We might want to open some of the blinds a little bit depending on the light, but the sun's going to set too, so it's fine. We'll adapt. We're nice and cozy. We meet usually the last Thursday of the month. There is code launch tomorrow, which Chandler and I are both involved in, as is improving. So we have adapted this month just because we thought it would be better than canceling. Okay. Let's see, we have a YouTube channel, which hopefully this is being streamed on. We'll find out. But if you want to find our past recordings and future events and aren't always free, check us out there. That's just CONDG is the URL there. While we're live streaming, please be considerate of our bandwidth, especially because I'll be using the internet for some of my demos today. But we do have a Wi-Fi code over there. So thank you for improving, for hosting us, providing pizza, all that good stuff, especially providing the last minute date change for us to accommodate for the event. We do have a raffle today with JetBrains, so you'll be able to get any JetBrains license you want for like a year, which is awesome. They do all sorts of development tools for all programming languages, and I love their stuff. Other groups in the area, we have Central Ohio Azure, which I need to attend more, but they are out there at the second Monday of the month, and they're active. The Global App Dev User Group is the third Monday of the month. They are included in this because they used to be based out of Columbus as the Central Ohio App Dev User Group, but very good group run by Sam, so if anyone knows him. I don't know too much of CBus data. They may be out there. They used to be CBus Pass, but if you're data oriented, you might want to check them out, CBus data. Code launch, the slide is incorrect. It's actually the 25th, tomorrow, and it is downtown at the Ohio Theater, I think is the name of it. So big place where I saw Hamilton and Wicked and all that good stuff. So this is a hackathon. You can see the results of 5 different teams, including Chandler and I participated on one team through Tech Elevator. So yay us. But it's going to be a fun thing tomorrow at 5. It's free, but you have to register. So if you want the URL for that, just talk to me or talk to Chandler afterwards. We'll get you hooked up. Meeting calendar. This is not Roslyn Analyzers. This is automating my dog, which is the weirdest talk ever. Next month is still technically TBD, though I think it's going to be on Cosmos DB with Sudoku, but I need to sort of confirm some final details with her, whether she's in September, October, or next year. But stay tuned for that. And then we'll have another talk in October. If you're interested in giving a talk, if you know somebody who might be, talk to us. We'd love to get you on the books. Okay? And if you have a topic you really want to learn about, talk to us too. We'll help you out there. December, we do kind of the Tech Life Columbus, like cross technologies holiday party, so we will not be meeting here, but instead be meeting in a larger party, which should be a lot of fun. Missed it last year due to COVID and students graduating and the like, but that's always a good time. Skip that because we did our lightning talks last month. So if you are looking to hire, raise your hand. If you are looking for work, raise your hand. Although I guess nobody here is looking to hire, so what's the point? But we're always happy to introduce you to folks. If we know that you're looking for something and know you're looking for something in particular, if we hear about it, we'll try to remember you and connect you. Right? So you can be part of the team. We got Alan, myself, Chandler, Steven. We don't have a picture for Steven yet, but we're running this strange ship at times. And we're always open to feedback, ideas, speaker suggestions, topic suggestions, that kind of thing. But on that note, I'm going to put on my speaker hat, and I will talk to you about this talk today was actually me saying, hey, what's the weirdest thing that I could submit to a conference and maybe get accepted? And I almost gave this at Stir Trek this year, but I realized that I needed an active internet connection to do that, and it's very hard to do that from inside of a movie theater. So this is automating my dog with Azure Cognitive Services. It's unlikely that you're here to try to automate your dog. So I'm assuming that you're here because you're wanting to hear a crazy person talk about his dog, or you're wondering what Azure Cognitive Services are, or you're trying to apply artificial intelligence to an application that you're developing or might develop. So if you are interested in AI, if you're interested in making applications do more with speech, vision, text analytics, things like that, this is going to be a really interesting talk. But if none of those things are boring, you'll still probably come away with this furthest talk of what did I just hear and who's this crazy man and what's he going to do to his dog. But just keep in mind, this is a kind of a joke talk to talk about Azure Cognitive Services and the things we can do with it. All right, so I'm definitely not going to be getting rid of my dog. For those of you who don't know me, I am an instructor over at Tech Elevator, where I just had the privilege of teaching a number of people in this room who have graduated either recently or long ago. We are really good at helping people get into dev, and we get great people to teach, which is awesome. So Azure Cognitive Services, if you're not familiar with what that is, it is a way of adding in AI capabilities to your application. So I can take an application, and instead of having to train like an in-depth machine learning model to recognize speech or to identify text characters. Thank you. That's getting a little. Yeah.
No light.
Yeah.
Just on you.
Just on me. Just on my eyes. Yeah, it's great. It's okay. I've had worse. You talk enough weird things happen to you that yeah, it gets interesting. But it lets you bolt on AI capabilities to an app without having to focus on training those, without having to focus on calibrating those. So imagine computer vision. If I wanted a computer to be able to tell me what it's looking at in any given picture, I'd have to show it pictures of everything and tell it what that is, and different light levels, different angles, different sizes, different orientations, that kind of thing. To teach a computer what a book is, there'd be a lot of pictures in one. Well, thankfully, Azure already has that for me in computer vision, right? That's one of the many offerings that we have in Cognitive Services. So I can use Azure's pre-trained models to identify images, speech, text, things like that, facial recognition. All these things that I don't have to spend a lot of time developing capabilities for, I'm instead calling out to their services and taking advantage of it, right? So I'm basically taking advantage of AI as a service, where I'm paying at a usage level. So the amount of data that I use, well, that's what I'm getting billed for. And we'll talk more about their billing amounts, but it's generally a lot more generous than you would think it would be, which is great. Okay, so high level, you can look at text and infer some meaning from it. You can look at images and infer some meaning from those. Speech, and you can generate speech, recognize speech. You can translate in real time from English to German. I think they actually do support Klingon, which I'm not sure why, but they do. By the way, people always assume that I know Klingon. I really don't. And then they have some kind of wildcard things that they put in the category of decision making, and that's content moderation, which is like, hey, is this gore? Is this nudity? Is this anything objectionable? They have anomaly detection, like, hey, is this wildly outside the norms? Is this maybe fraudulent behavior in a system? And then they have personalization. They call it personalizer, but it's really building like a recommendation system like Amazon or Netflix or Spotify or something like that. Okay? So they've got a lot of different things we can do with Azure Cognitive Services. And so I thought about this and I said, well, if I put together a talk and I thought about my dog. My dog is Jester, the Cairn Terrier. He's 5 now, but that's him as a puppy on the left. And he's a really, really, really good boy. But he's a Cairn Terrier, and terriers like to bark, right? So he does a lot of barking. And I feel sometimes that Jester is overworked. And I thought, what if I built a system that could take some of that stress-inducing work that he's doing about watching out the window and barking at things that pass by? If I built a system that would bark at things for him, he could just enjoy playing and snuggling and doing all those things, and we'd have a quieter life. And so, I swear that I am a sane man. I'm just having some fun with Azure Cognitive Services here. And so I said, how would I build Jester if I'm building him with Cognitive Services? And so I broke it down to the capabilities he has, the user stories here. So he looks outside, he looks for animals or burglars or whatever it might be. And if he sees something that he doesn't like, he barks at it to let us know. Even when we already know, he still barks at it. Lovely dog, but likes to bark. He occasionally will listen to the words that we say. And when I say words, he will react to them. If I tell him compiler, he's not going to react to that. But if I mention car, yeah, he's gonna listen pretty intently to that word, or treat, or walk, or whatever it might be. So Jester infers some meaning from individual words. But he also knows phrases. He's a very smart dog for such a small skull, but he's very smart, and he can understand, hey, do you want to go on a walk? Or would you like a treat? Something like that. He infers meaning from these commands. And so what we want to do is we want to basically use Azure Cognitive Services to replace some of these capabilities so Jester can live a happier life. So specifically, we want to look at entity recognition, sentiment analysis, language understanding, computer vision, text-to-speech, and speech-to-text. There's more that we could do, but that's what I'm covering in depth today. So entity recognition, that's where we're getting a sentence like, do you want to go to the vet? Right? There are some entities in that sentence. You know, you might be an entity, vet is certainly an entity, right? So he might understand the sentence and say, hey, there's some things that we're talking about. Do you want to go to the vet? You're like, no, not so much. Do you want to go to the park? Oh yeah, that sounds great. Do you want to go to grandma's house? Oh, absolutely, I love it there. That's entity recognition. We are recognizing locations, people, things like that inside of a sentence. So given some string, we can identify some entities inside of that string. Sentiment analysis is basically, hey, is this sentence positive, negative, or neutral? So if I say Bill Gates is a person, that's neither positive nor negative. That's about 0.5 on the 0 to 1 scale. If I say Jester's a very good boy, well, that's closer to the 1. That's a positive thing. And if I say this code is awful, there's no way in heck this ever worked, well, that's probably more towards the 0 scale. It's a very negative sentiment. So you see sentiment analysis used a lot with social media, where you might look for tweets about a certain topic and then see what's the sentiment over time, right? So that's sentiment analysis. We have spots over here in the front if you want to come in. Language understanding, or LEWIS, I'm not actually sure where they got the I and the S, but they call it LEWIS. Language understanding is really a lot like She Who Shall Not Be Named, a little device from Amazon, sits on your table, listens to words, and lets you shop or play music or whatever it might be, right? It's listening to many different things you might say and trying to match it to an intent that it knows about, such as set an alarm for 5 p.m. or what's my current notification, or that play that funky music, white boy, or whatever it might be, right? I'm sorry, I'm musically illiterate. But that's language understanding, where we know certain different intents and certain utterances that might be uttered to match those intents, and we're kind of matching to it. Computer vision is what I described earlier. Microsoft has this pre-trained model that knows many different objects, and we're using their pre-trained model. If we wanted to, we could use custom vision, which lets me give it my own images of things and teach it what things are. So if I wanted to teach it if I wanted to provide a bunch of pictures of Jester's toys and train a model, that would be custom vision. Like Microsoft didn't go out and take pictures of all the little toys that we have around our house, thankfully, because that'd be really creepy. But if I needed that for an application, I could do that with custom vision. Then we have things like optical character recognition, facial APIs, things like that. Text-to-speech, speech-to-text, they're pretty much what you'd expect. Taking a string, converting it to spoken words, taking spoken words, converting them to a string. Okay? So taking all these things, we can basically build a terrier. Well, not really, but we can kind of emulate the main functionality of my dog, so that he hopefully can live a quieter life. So, yeah, he is such a cute dog. I honestly, I feel like I put together this slide deck just so I could show you pictures of my dog. But let's just take a look at this application in action, and before we start looking at the code. Okay? By the way, I have all this code available for you to take a look at online afterwards. I'll give you a URL for that at the end. I'm going to be showing you slides of the code, so we're a little bit more focused in on things, but we can also drill into the code more particularly for the question and answer. So if I run my application, it's just a simple .NET console application.
Hello there.
And it speaks. So you launch the application and it says, hello there. Welcome to Automating My Dog by me. And it only supports a couple capabilities. First thing it can do is look at pictures. So it wants to look at pictures, so let's do that. It lists out a bunch of pictures. And I have a decent number of pictures here, which actually I seem to have misplaced, but let's go into that. Automating My Dog, images. Oh, come on, computer. I have several fezzes actually. Extra large icons. I don't know why my zoom wasn't working there. Which one do we want to show?
Squirrel.
Which squirrel? You're gonna have to be more specific.
The one on the stump.
The one on the stump, squirrel stump, got it, okay. So that would be choice number 22. And it's now calling out to computer vision. It did it in, a second or two. And it says it generated a description of a squirrel eating a nut with a confidence score of 51%. Pretty low confidence, but it's actually pretty accurate generation. These descriptions tend to have lower confidences, but they tend to be pretty good. And it says, hey, here are the tags. Here's everything I noticed in this image. Animal, mammal, squirrel, outdoor rodent, tree, ground squirrel, gray squirrel, Douglas squirrel. I don't know how it could be both a gray squirrel and a ground squirrel. But it's giving me confidence for each one of these things. So it's not going to be terribly accurate as far as the breed of squirrel, I would say, unless I trained the model just for that. But it's telling me that, yeah, this is definitely going to be a squirrel. It gives me some categories, it gives me some objects it detected, and when it detects an object, it actually gives me the upper left corner in the picture. So this is the 53rd on the X pixel, and then 149 on the Y, and then like the width and the height. So we could basically draw a bounding box around this image if we wanted to and say, hey, here's where the squirrel is. And now I'm going to hit enter and we'll see what Jester thinks of this.
I saw a squirrel eating a nut. Bark, bark, bark.
It's hard to generate text to make some bark, but we're going with it, right? So there we used. We could try, right? So we used a couple different things, right? We used computer vision to show it an image. It tagged all the things that it saw in that image, and then based on those tags, the C# logic that I wrote just said, hey, one of these things was a squirrel with a decent amount of confidence. I'm barking, right? And then it just grabbed the topmost one. But if I showed a picture that doesn't have a squirrel in it, such as this one right here, hopefully it doesn't see a squirrel there. We will see what it reacts to there. So I'm going to show it CONDG.jpg. Some of these it takes a little bit longer for the more complex images. It found a lot of people in this image. And let's see what it thought was the main description.
Nothing to bark at, but here's some things I saw. A group of people sitting at tables, person, clothing, man, indoor.
Which honestly is pretty accurate for an image that it's never seen before, right? And it identified, let's see, 1, 2, 3, 4, 5, 6, 7 people in that image, and it gave us bounding boxes for each one. So that's pretty cool. So some other things it can do. It can listen to commands. So if I hit 2 here, it's going to listen to the mic, and I'll tell it what I want to tell Jester. Do you want to go on a walk? So it detected that my language spoken was English, and it identified some key phrases in there, such as wanna and walk. Okay, so already we can understand maybe a little bit of that just from looking at that. Sentiment is 87, so halfway between neutral and positive. And then the reaction to that is now going to talk to Lewis, language understanding, and it's going to see, does that match to any of the commands that Jester knows about? Because I've set up some commands that Jester can react to. It's actually only 2 commands, but it's going to go out there and see if it matches to any of the
Yes, Jester does want to go on a walk.
And it thought with 95.9% confidence that it was trying to talk to the walk intent. So this is a ridiculous application, right? Please don't go home and try to automate your pet. But you can see, like, if I've got an app and it's connected to a webcam, I could maybe press a button to take a picture and send that off to Azure Computer Vision. If I'm looking at a tweet or set of tweets, I could do some textual analysis and analyze some key phrases, sentiments, things like that. Right? My goal is always to use technology the weirdest way possible, because that's just what I like. And then the third option here is just react to type commands. So if my mic wasn't working, I could type in, is Jester a good doggo? And that's basically shortcutting, so I'm not using my microphone. So identified entities and key phrases as Jester, generally a positive sentiment.
Jester is a good doggo.
And then it matched the good boy intent. Now, if I give it something that might overlap 2 intents, I might say, Jester is a good boy, or a good boy, rather. Does he want to go on a walk? And yes, I do talk to my dog. So here we see key phrases, Jester, good boy, walk. Very, very, very positive sentiment, almost 100%.
Oh yes, Jester does want to go on a walk.
Apparently I typed the wrong thing because it only matches the walk intent. But if I have something that's maybe halfway between the two, it's going to list the intents that most closely match it. Okay, so that's the simple app. And we're going to talk more about the code for how to do this now that we've talked about more what this monstrosity is that I created with my free time. But any questions before we drill into the code?
It's just a wonderful walk to the vet.
You know, he actually likes the vet, so yeah, you know, they play with him there, and he gets to play sometimes after we get the vet. Yeah, he likes the vet. He's a weird dog.
Bye, friend.
I have a quick question. Do you ever put in like words that like some that connotate like a positive and some that connotate like a negative, and kind of see how it plays out?
Give me a sample phrase.
Well, I think you just said one, but you said that's a positive thing.
Okay.
So,
Hello there.
Let's try this one.
is car positive or negative?
I think that's probably neutral.
Okay.
Here's one. Good riddance. Sentiment was 90%. So, you know, it didn't quite infer the hidden meaning there, right? You know, it's better than I could do on my own without having specific cases. And that's really the idea behind Azure Cognitive Services, is a shortcut to building something bigger.
How about not bad?
Yeah? Okay, let's try it.
I don't understand.
Don't hit enter fast is my takeaway there. What was your example?
Not bad.
Not bad. Not bad. Not good, but not bad. The speech recognition is actually really good. I've only seen it go wrong a couple times. Sentiment 87%. So a little confused, you know, but that's okay. I'm not sure how I'd, you know, mark that. Maybe 60, 70, something like that.
I don't understand.
And it didn't match any intent. It matched maybe the walk intent, but not strong enough for it to understand it. Okay. Yeah, what you got?
If you haven't looked at the same picture again, will it like generate the same amount of like its confidence in what it is?
Yeah. So the image recognition does seem to be deterministic. So like it's always going to generate the same responses. However, if I showed it an image right now and then I showed it the same image in 3 months, Microsoft has always updated their models, right? They're improving the performance of the models, adding in new tags and things like that. So it might identify different things in the future after they've pushed out updates. But if I'm doing 3 things in a day, it's going to give me about the same exact thing. So, you know, I could have given that talk at Star Trek or somewhere else without Wi-Fi if I had kind of hard-coded the responses and saved the audio files. But that's just a little too much ninja demo magic for me. Okay. So let's jump back to our slides and we'll kind of look at how the code for this works. Okay. So in order to do any of these things, we need to have an Azure account. If you don't have an Azure account already, you'll want to go out there and create a free account, which gives you a lot of free services for a year, and then like $200 of free credits for your first month as well. But the stuff that I'm doing here, I'm being charged maybe cents for, if anything, which is pretty cool. But everything that I'm showing you relies on an Azure Cognitive Service instance. So I create one Azure Cognitive Service, and then that lets me do all of those things against it, like the text analytics, computer vision, custom vision. It's just this API that lets me do it. If I wanted to, I could create an individual like computer vision resource and a sentiment analysis resource separately. So I'd have separate billing information for them. But usually it's more convenient to have a central Azure Cognitive Service instance. This is not something you get billed for unless you use it too, so that's nice. Okay. So you'll create one of those, and the billing. So here's the billing breakdown as of last week or a couple weeks ago for their vision-related things. So we can see if I'm doing 0 to 1,000,000 transactions on tagging images, I'm getting billed $1 per 1,000 transactions. So for me testing this, building this app, I might have gotten billed a couple bucks. Demoing this here, it's pretty trivial. But if you're distributing this application to a bunch of users and they're using it on a regular basis, you're starting to amass a lot of expenses potentially. Okay. Some of these services cost a little bit more than others. You know, tagging images in particular is more expensive than just looking at what colors are in the image or understanding what the image type is. And some of these requests, as we'll see, we can do multiple things in the same one, so those get a little bit more expensive as well. But generally, it's pretty reasonable. Language requests, so text and speech and things like that, those tend to be maybe a little bit more expensive, but you still have that healthy per thousand thing where you're paying dollars per thousand requests. So perfectly usable on a small app like this or for learning purposes, but you start selling an app around it, you're going to get some sort of an ongoing expense as people use it. And that'll scale up and down with usage. But disclaimer, always check the Azure price calculator. And expenses do differ based on the Azure region that you're in. I tend to use US East and US Central, but if you use a different one, you might see different cost profiles. So doing all this stuff, we can do it from any language because this is just an API, but Microsoft has a wonderful SDK out there for .NET. So if you're going to get started in C#, what you'll want to do is you want to open the project up in Visual Studio. You want to go into NuGet Package Manager for your project, and then you're going to want to add in references for the various libraries you want. So this application used Lewis, Text Analytics, Computer Vision, and Speech. So I had to add those for external references, right? So text-to-speech is pretty simple. We give it a string, we tell it what voice it wants, and it generates some audio. We can save that, or we can just play it to our speakers. So the code to actually make the computer bark was about 4 lines of code. I create a speech config here, where I'm giving it my Azure Cognitive Services key, which is kind of a protected key that we'll use. And then we tell it what Azure region that's located in. So that's going to be something like North Central US, something like that. And then we tell it what voice to use. There's a list of voices that they have. The ones that end in neural use neural networks to sound a little bit more human-like. When I tested a bunch of different ones, I fell in love with Guy Neural just because it sounds so much like the dog from Up. Like, yes, that's definitely the voice I'm going with for this application. But you can get like a British voice if you want, male, female voices, but generally look for the neural ones because they tend to be a little bit better. I'm not certain if there's a pricing difference though. Next thing you do is you create a speech synthesizer, and then you call synthesizer speak text asynchronous, and you give it some string. So the string there might be hello there, or I would like to buy some pizza, or whatever it might be. And it's going to just, speak text is going to actually speak it so the user can hear. So that's what we saw. But they have other ones that will let you download it as a stream and save that in the file if you want. Okay. So if my application used the same audio clips over and over and over again, it would make sense to generate WAV files or something else and just play those instead of having to regenerate the same audio from Azure all the time. So that's speech synthesis. Speech to text is about as easy. So you're creating a new speech recognizer using the same sort of speech config, and then you're calling recognizer recognize once async. You're awaiting the result of that, like we're doing right here, and once that completes, you have a speech recognition result. The result might be canceled. I'm not sure what it takes to cancel a speech recognition. I've not seen that happen. No match will occur if you didn't say anything, if your microphone's not working, or it just really couldn't make sense of what you said. Usually no match means your microphone's having some issues. And then recognized speech is just going to generate the string that you said. It seems to be really smart about this. It waits long enough for me to start talking, and then it detects that I've stopped talking. I don't know how well it performs in noisy environments because I'm usually testing this in a basement somewhere. But this tends to really be very accurate. I've been very pleased with speech recognition. Yeah, I was trying to work that day. He did not want me to work, so yeah, these are good problems to have. Computer vision. So computer vision has a really nice API where we basically tell it what we want. So we're building out a list of features that we care about in an image. Let's say I want to get the categories, description, that's basically the caption, the type of image it is, maybe colors that might be in it, tags and objects. Each one of these, I think, actually counts as a separate request when I'm making my request. So even if I'm making one request, these are like 5 different requests to the API, right? So keep that in mind, and don't do ones that you're not going to do. So for example here, I have image type, but I'm never actually looking at the results for the image tag. If you just want to get the subtitle for an image, just call it the description. That's all you need. Okay. But then you basically you give it an image stream. So it's a analyze image in stream asynchronous. You give it the source of the image, which I'm just loading it from a file on my disk, but you can grab it from webcam or whatever you want to do. And it generates back this image analysis result, and that has the results to all these other things that you requested. If you didn't request a description, it's not going to have a description on the result. I mean, like, it'll be there, but it'll be like an empty list or null or something like that. Okay, so you're using this one API to request all these different things, which is really cool versus having to make 5 different requests in a row. It'll generate back a list of captions, which just basically gives you the text and the confidence of that text. So you're just looping over it. I've only seen this generate 1 caption per image. I believe that it gives you a loop here because there's some methods that you can give it multiple images at once, and it will generate results for that. Okay, but generally the first result will be the caption of your image, which might be a squirrel sitting on a stump eating an acorn, something like that. Tags and categories are very, very similar, right? You're just looping over the tags collection, the categories collection, and they have a name and a confidence score. That confidence ranges from 0 to 1, with 1 meaning I'm 100% certain and 0 meaning I have no idea. Categories I've not found to be terribly useful, but tags are really, really useful, and they're also the most expensive thing to bill for as far as like per 1,000 requests go. I think it's $1 per 1,000 requests versus other things are like 60 cents or something like that. Objects are a little bit more complex because you get not just that the object was present, but where it was on the image. You get a bounding box around it. So when I gave it the image of us sitting around these tables at CONDG, it gave me a bounding box per person that we could have drawn on that image if we weren't doing a console application. So that's really helpful for, like, if we're trying to build a self-driving car or something like that, we might use these bounding boxes. Now, disclaimer, don't build a self-driving car around Azure Cognitive Services because you don't want to have to wait for the internet as you're driving down the road. But just please don't. I've already worried enough about other drivers. But if I was just giving it something as a low priority image, then yeah, that's really helpful. Okay, so I just got an idea for another project. I could potentially train a custom vision thing around Waldo, show it to Where's Waldo book, and ask for bounding boxes around Waldo. I kind of want to try that now, but that could help. Right? Sorry, this is why my brain does to me. So this is kind of what we see when we're generating some of these things. So we get the tagline, the tags, the objects, and where they are in the image. All right. So text analysis, believe it or not, it's a lot easier to work with speech and images than text as far as the APIs go. I had more issues with the text analysis than anything else in this project. So most of my issues were around language detection, because when you're making a request out to something with text, it wants to know the language and the language code to use. So the first thing you do is you go out there and say, hey, here's my message. What is the language that this is going to be in? Right, so I'm creating a text analytics client. I'm giving it my cognitive services key. I'm telling it what endpoint to use. This is going to be something like Eland.AzureCognitiveServices.net, whatever it might be, right? Like, so it's an endpoint that you'll find on your in Azure portal for your cognitive services instance. And then we're calling client.detectLanguageAsync. You're giving it the text, which is just the message to analyze, but you have to give it a country hint. It will error for you if you don't tell it like the default country. And I'm not sure I like that. Like, that doesn't make a lot of sense for me if I'm trying to build a global app to work with a lot of different users. If I hard code it in US, well, that might serve most of my users, but what if somebody's using it in Canada or France or something like that? You know, so that's something that you might want to have people be able to set as an option in your app, or customize it based on where your application is running. But once you get that, you can loop over the resulting languages and get the confidence score. It's almost always 100% confidence that it's English when I use it. But you could try giving it some French and see what it says. Key phrase detection is really good for just boiling out the noise of a sentence and identifying the key entities. We saw wanna and walk as our key phrases for do you want to go on a walk earlier. This is where we're calling out to client key phrases async. We're telling it what language that we're working with. And then we have to provide that here. So generally we get the first language, and then we can use that to provide the language, or you can hard code that it's English. I wish that the language APIs were a little bit more forgiving, a little bit more flexible with different languages. That's the one gripe I have about Azure Cognitive Services. Everything else is just really dreamy to work with. But then you just loop over your key phrases and you can just display them to the screen. Note that there actually isn't a confidence score associated with it. This is maybe the only thing that I'm showing you that doesn't have a confidence score associated with it, aside from speech recognition. Entity recognition, this is something like car, ball, toy, you know, that kind of thing. So if I'm looking at a sentence, it's going to recognize my locations, nouns, and things like that. And again, it's client, entities, async. I got to provide the language code. All these things are fairly similar to each other. So once you got one, it's going to be pretty easy to move on to the next one. But again, with the text stuff, you do generally need to tell it what language to work with, at least in my experience. Sentiment analysis, very similar, gives you a score from 0 to 1. And that score, you know, may be misled a little bit by the idioms of English, but it's probably better than I could do with a week's worth of work, so I'm happy to use it. Unless the bulk of what we're doing is like sentiment analysis, in which case I might want to see, just find some better options. But generally, I'm very happy with everything. So when I'm looking at the string Azure Cognitive Services is really awesome. It says, okay, that's definitely English. Key phrase here is Cognitive Services. Entities are Azure Cognitive Services and cognitive computing, which is interesting because cognitive computing is not actually mentioned in that. So I'm not sure where it got that, but it did. And the sentiment is pretty positive, and it wasn't sure what intent to match that to for Jester, because Jester knows two things. He knows good boy and want to go on a walk. I could teach it more, but you know, I'm a lazy man. So language understanding. I wish I should have used a GIF here, because, or GIF, depending on your religion, because when I'm talking to my dog, he's just tilting his ears back and forth, trying to figure out what the heck I'm saying. Okay, so language understanding is really very similar to She Who Shall Not Be Named from Amazon, right? If you're familiar with that, they have different actions you can do, such as I want to add something to my shopping cart. I could say, please add Azure Cognitive Services in a nutshell to my shopping cart, or let's buy, you know, X, Y, Z. So there's many different things I could say for that one specific intent. So an application can have many different intents, such as what do I want to do, and many utterances per intent. So for good boy, for example, that might be an intent, as is walk. But if we're looking at walk, there's different things I could say. I could say, hey, let's go on a walk. Jester, would you like to take a stroll? What do you think about taking a walk? Would you like to go on a walk? How about we go outside? Something like that. So people say things differently, and the same person says something differently 3 or 4 or 5 times. So as people use your application more and more and more, you can add these utterances to existing intents to make your app a little bit more precise. Now, the really cool thing about this is that if I'm modifying Lewis by adding another intent to it, adding another utterance for an intent that it already knows, I don't have to redeploy my application. I'm just retraining Azure Cognitive Services on that new thing, and all of a sudden people who are already using my app have a little bit more accuracy, which is neat. Testing it's really hard because you have to test it with all these different things, but it will actually automatically test it and tell you how well it's performing. So utterances, multiple utterances go to one intent, and intent is basically just what your app can do. When we're working with Lewis, there's a lot more code in order to work with it compared to some of the other stuff that we talked about. So we have to create some credentials, which is just usually a new API service client credentials object, which is a very Java sounding name. It's just that long, right? And we're giving it our cognitive services key. We then create a Lewis runtime client. Remember, Lewis is language understanding. And we're passing it the credentials, so it knows that we have permission to access our account. We're giving it our endpoint, which again we can get from the portal in Azure. we're telling it our application's ID. When you publish a new Lewis app, it actually creates an application registration out there, and it gives you like this GUID that represents your app. So there's like 5 different things you have to know about your app in order to configure this, which gets a little nasty. There is a production slot and a staging slot, so if you wanted to test it against like stuff you've trained on without other people using it, you could test it against the staging environment if you wanted to. But once you have all the configuration stuff set up, you're going to call out to Lewis. You're going to create a prediction request. You're going to say, hey, I want to go out, get this prediction. Here's the slot I care about. Here's my app, and here's the request. The request is just some text. It might be like, hey, Jester, do you want to go outside? Like, that's a string it might be. And then it's going to give you back a prediction, which gives you back key value pairs of strings and intents. So string here would be the name of the intent, which would be like walk. And then you can look at the value, which would be basically your score, the confidence score of that. So you can see, hey, what was the score that we matched the most? So which is the most likely thing that the user was trying to say? Sometimes the application's really split. It's not sure if you mean one thing or another. And in cases like that, you might want to ask the user to clarify what it wants. But a simpler approach is just always to go with the highest score if it's above a certain threshold. I found that if it's 65% sure about something, it's usually good to show to the user. And if it's below that, it's usually good to show the user, I don't understand, can you try saying that differently? Or here's some things you could say. So here we go. So who's a good boy that would like to go on a walk? That's the one I was trying to do earlier. And it matched to the walk intent. That was the top intent. And that's what it gave me back. Okay. But if it matched to the other intent, I could actually give it more utterances to train it, to help it calibrate it, to know what I want. So kind of cool stuff. So if you're curious about this code or about the slides, you can go out to matteland.dev/doggo. You'll be able to get the slides and the code on GitHub for this. You can't just clone this to your machine and run it though, because I'm not going to give you my cognitive services key because I don't want to get your bill, right? So you're going to have to actually go out and put your own values into your own configuration file. But I believe I have an example in my app on how you might do that. So if we are stopping and looking over here at the configuration manager, your config file is going to look something a little bit like this. Right, you're going to have this, your URL here, cognitive services, your cognitive services key, that kind of thing. Okay, and I'm always happy to answer questions on LinkedIn, Twitter, things like that. Right? Any questions, any code that we want to go over more before we kind of close out? So I think code on slides is usually easier to focus on, but I'm happy to go in depth on anything we want to.
So is there a way to keep track of how many times you've called the API while you're doing this? Like, is there some way to have a counter in your app so that like you can see the bottom right of the screen, like so many calls to the API, so that you're not accidentally wrapping up a big bill doing this?
So I could always have an integer that saves to configuration file or something like that locally, but with Azure, we can always go out to the portal. Nope, I don't want to log in with my university credentials. I want to log in with, nope. Let me open up the evil browser I don't like to use very much. You can't tell I'm a Microsoft guy. The problem of existing in multiple contexts. Okay, that is me. So if I'm looking at, automating, let's just look at all resources, and I'm going to look at cognitive services. Okay, Lewis Doggo and Matt on Data Science Cog Services. Okay, so this is my cognitive services instance that I use for everything, and I can kind of go out here and I can look at cost analysis, and it'll tell me a little bit more about what's actually costing me things. I can look at usage, metrics, and things like that as well. We'll see how the demo gods are treating me here. But, Whoa, this is a really
Wow.
expensive talk for me.
Wow.
16 cents.
Just for today? In one day?
Let's start a GoFundMe for
Not even
that.
1 hour.
No, that's since yesterday.
Oh, okay.
I got pizza out of it, so I think we're fine.
That's
Yeah.
But I can also look at metrics. I can look at usage metrics, calls in. Let's see, total calls. I think is more closely aligned with you. So we can see total calls on any given day, and I can aggregate by the day and all this stuff. Like we have a lot of really cool cost analysis tools and metrics and everything like that baked into Azure Portal. So we have the full power of Azure behind us, and these things are really consistent between services. So if you're familiar with an app service, you'll be familiar with metrics for here too. So, good question. What else?
More on the pricing. So you said that for every 1,000 calls, if you're under that for the month, does it round up or is it like prorated for how much you use?
From the prior screen that I showed, my guess is it's prorated, right? Because I didn't say $1, right? So I don't think it rounds up. I think it just charges me the prorated 16 cents. But you all are worth 16 cents, maybe even 17 cents.
Dang.
Yeah, it's your birthday, you're fine.
Yeah, that'd be good.
What else?
So if you get the results back from, say, their image recognition, and you realize the results are pretty close, but there's 1 or 2 things that it got wrong. Like
Yeah.
it labeled something as a squirrel and it's actually a fox.
Yeah, I think there's actually an example with Chipmunk here,
Yeah.
where if
Can you send feedback back to Azure to say, this was, misrecognized, mislabeled, and next time if it's actually a fox, or is it just sort of like a one-way street?
So I think it's more of a one-way street, but here's why. A lot of the stuff with machine learning in particular, it's all fuzzy, right? Anytime you're using anything with machine learning, artificial intelligence, you're always acknowledging the possibility that you're wrong. Either it's going to not highlight a person or it's going to highlight a beach ball as a person, right? It could go 1 or 2 ways of making, yeah, that's what I was going for, so thank you. When you're using AI or machine learning, you are acknowledging the fact that it may be wrong in some cases. You test it pretty thoroughly in a lot of different environments, but you have to be okay with it potentially being wrong in some cases. You try to minimize that, but that's sort of a risk that you associate with. Now, I show it a picture of this room and it says, oh, that's absolutely a sandcastle. Yeah, I might want to probably ping Microsoft on Twitter. I'm just saying, I think you guys might be having some issues. But that's the downside with computer vision is I can't tweak it, right? It's out of my control. I'm saying I really want to use your library of recognition stuff, and if it's wrong and I don't like it on some things, well, I need to probably train my own or use something else.
So you can't take advantage of theirs in addition to the custom vision? It's sort of either one or the other?
I mean, I could use computer vision to see if I find something specific that I'm looking for, and if I don't, I could try custom vision, but that's probably more complex than I need. The downside with custom vision is you need a lot of pictures to train it, right? And you're getting pretty deep into machine learning at that point too, which is almost defeating the point of Azure Cognitive Services. The point of Azure Cognitive Services is I don't have to be a data scientist to use AI and machine learning capabilities. They give me an API and I can just go and run with it. But again, if you're worried about the cost, free account, it's free for 12 years, or 12 months. 12 years would be nice. Anything else?
So in your app, when you are talking into the microphone, you've got 2 different steps there where it's recognizing your speech, and then it's taking that text and firing it off to these other.
Yeah. So step
What
one.
is that? I mean, I don't know if it gets too deep. Could you look at that in the code?
Oh, sure, yeah.
How it does that? How it goes
Happy to help.
from
All right.
one to the other?
So
that chain of events.
So I got a menu here, right, which I'm basically setting up a bunch of different objects that are each for image, speech, text, and language understanding to kind of organize the code for you all. And if the user types in 2, they want to do speech recognition, well, I'm going to call out to listen to spoken text. I get back a string, and then I'm basically calling into my respond to text command, which then basically says, hey, if they gave me something, if they might not, if their microphone might have had issues. I was testing this a couple days ago. I forgot to turn on my mic, so That's where it starts going out and saying, okay, now I'm going to go out and analyze the text, and now I'm going to go out and talk to Lewis and get the intent that matches, right? So this is just C# code that happens to talk to Cognitive Services.
Yeah, I was just curious to see.
Yeah. And this code is all out there on GitHub. I need to put it in a README file. Today I was going to do that, but I'm like, nah, let's go to the zoo instead. This is my day off. This is kind of a recharge week after my wonderful students graduated. But yeah, I'm going to put a README file out there, but I'm always happy to chat over the code too. I find that people tend to get lost in code that they didn't write, especially when there's a lot of it, so slides help with that. Yeah. But really it's just flowing from one to the other to the next. Okay. Yeah, he loves that. He uses that as a pillow all the time. I don't like my dog. If you didn't get that, right? Like, so if I wanted to automate Jester, I could go out there and I can use Azure Cognitive Services to detect objects of interest with computer vision. I can speak to it and get spoken to with text-to-speech and speech-to-text. And I can use those features in text analysis and Lewis to kind of get some sense of what we're talking about, right? So if I wanted to keep developing this bot, I could teach it more and more intents and give it more and more capabilities by adding new intents in Lewis in the portal, and then add to my switch statement in my code where it's looking for walk or good boy or whatever, just my new intent. So the next task for this project, it's right now constrained to its mortal coil in my application. It's a console app. So I really need to get some robotics involved, either that or get like an overhead rail and just some unit that just rolls from window to window, because I need this thing to be able to look out the window and spot squirrels so Jester can rest. By the way, this bot is a real thing, so our world is terrifying.
Yeah, when that thing's fully armed.
And
You see the one with the Russian guy put the machine gun on top?
Yeah, the world scares me. Right? We're getting into Black Mirror pretty quickly. And it's all because of people like me who said, hey, wouldn't it be cool if? And then someone in the military sees it and says, yes, it would. Anywho, we used a bunch of different pieces of Cognitive Services to make this application run. Now, I could add in more things. I could teach Jester to recognize my face and my wife's face using the Face API. I could teach Jester or the virtual Jester to recognize his toys with a custom vision, right? Because Microsoft doesn't have images of those toys. I could teach Jester to recognize the voice of someone speaking using speaker recognition. So you can retrain someone on someone's voice and say, okay, that's definitely Matt's voice or my wife's voice or whatever it might be. I can even use content moderation to censor the bad words that I might say as I'm coding if I don't want Jester to hear them, right? Like there's a lot of different things I could add to my code to make it work. But I can't talk about Cognitive Services without talking about chat, because chat is a feature, or conversational AI is a big feature inside of Cognitive Services, where we have the ability to use the Microsoft bot framework to basically build a chat bot, and that's powered by Lewis as well. Sentiment analysis plays a key factor, language translation, things like that. So you can basically build an interactive chat bot using Microsoft's technologies, and that's kind of what I'm playing with in my spare time now as I can. Going to be exploring some uses of that potentially to help students, but also helping people find articles of mine that I've written or videos or contents like that. Really just for fun. So this is sort of me, an early prototype of me trying to put a chatbot on my own website to help people find, upcoming talks or articles or things like that. So it's all very related to Lewis in particular, but it's technically part of Cognitive Services as well. There's also something out there called Q&A Maker, which basically if you have like a knowledge base or a Word document or something like that, you feed it into it and it just generates all the intents for you. It's like, oh, cool, so cool stuff.
So could you train the app to recognize different voices, and so it'll listen to you if you give it a command, but it won't listen to me if I give it the same command?
Absolutely, yes. And now you're getting into my sinister plans with launch missiles intent. For legal purposes, that was a joke.
Abort the launch, abort the launch. I'm sorry, you were not Matt Eland.
I'm sorry, Matt, you didn't give me a cookie. So once again, the code is available out there at matteland.dev/doggo. You can also go to matteland.dev if that's too hard. and there'll be a link there to this site. I'll get a README file out there at some point, but I've got a lot of stuff I'm trying to finish before the end of August. And I got more articles out there at accessibleai.dev. I need to put more stuff out there on cognitive services, but if you're interested in machine learning, AI, Microsoft, there's a lot of stuff out there for me on there. Microsoft has a ton of really good learning resources out there as well. I've learned a lot from Microsoft. They also have a couple certifications you might be interested in, such as the AI Fundamental Certification or the AI Engineer Certification, which is more in-depth and focuses more on the stuff in here. Thanks for being awesome. What questions do we have that we haven't covered? Cool. Y'all ready for some free stuff? Would you get the lights?